Well, good morning or good afternoon, E-Techians. Today we're going to talk about how to draw an energy diagram, which you'll be doing as part of the Discovering Energy Lab. First, let's review a little bit about what we talked about yesterday. We said that energy is the ability to make change in the environment, and energy is contained in the environment in several ways. We talked about kinetic energy. Kinetic energy is the energy contained in an object because it's moving really fast. So it has mass, it's moving really fast. That's like the kinetic energy of a baseball, for example, that's been thrown really fast. It can make lots of changes because it's moving and it's going fast. Now we're going to abbreviate that KE because it takes a lot to write out the word kinetic energy. Then we have gravitational potential energy, and that takes a long time to write down. We're going to call that GPE, and that's the energy stored up in an object because it has height above some reference point, the ground or your head or something like that. So, if I hold a base or a bowling ball over somebody's head, right, change can be made when I release that ball. So that's gravitational potential energy. We have elastic potential energy, and this is the energy associated with a stretched or compressed material. We're going to abbreviate that EPE for elastic potential energy. We have chemical potential energy. Now this is the energy stored up in chemicals, right? Like your gasoline is an obvious one. The chemicals in a battery is another. The fat on our bodies is chemical potential energy stored up. Sugar has energy stored in it. We're going to call that chemical potential energy. Okay. And finally we have thermal energy, sometimes called internal energy. We're going to call it thermal energy. And thermal energy is the energy stored in the random motion of atoms and molecules in a material. For example, if you have really, really hot water, the molecules of water are moving really, really fast compared to the molecules in cold water. And those moving molecules, they can affect change, right? So we're going to call that TE for thermal energy. Now these are all ways that energy exists in the environment, but energy can be transferred. It can move, it can flow. And we talked about several ways that can be done. We have work. And work is when energy is transferred through a push, right? A force is applied and through a distance, and thus energy is transferred from one system into another. We can transfer energy using waves. We can do electromagnetic waves. I'll just abbreviate that E&M waves, electromagnetic waves, or sound, or lots of other kinds of waves, water waves, slinky waves. We have slinky. You can have energy flow through a slinky or a rope or whatever. Anything that can have waves in it is transporting energy, transferring it. Okay, and then we talked about friction and conduction. I'm just going to call that heating. And heating is a way of transferring energy, and this is through through friction or the conduction. Conduction is when you have, like, let's say over here you've got lots of molecules that are moving really, really fast. They're hot, and over here you have cold molecules. They're hardly moving at all. But if there's a boundary between them where they can touch, these fast-moving ones will kick these, and that motion will eventually spread throughout until everything's at the same temperature. And that's called conduction, and that's energy, really thermal energy spreading through a material through conduction. So anyway, now, by the way, this list of the kind, the way energy is stored in the environment, the way energy is transported or transferred in the environment. This is not comprehensive. This is just what we're going to use for right now. Now, let me show you a little toy, and we're going to draw an energy diagram using this little toy. So this little toy, we wind it up, okay, and then I release it, and it moves until it stops. Okay. Now, what we want to do is look at these series of changes with a diagram that kind of explains what's happening with the energy. So first, at the beginning, this doesn't have any energy in it, but my hand does. Okay. The muscles in my arm and my hand have energy stored in them as chemical potential energy. Then I do work by applying a force. I twist this little knob right here. I twist it. And that required me to apply a force. And that transferred energy from my arm into the little spring. There's a little wind-up spring in this car. You can see right here, you can see a little metal tab. And inside here is a coil. And when I twist this, I'm forcing that metal coil to wind up, and then it releases that energy when I let go of it. Okay, so I do work, and now the energy that used to be in my hand is now stored as elastic potential energy in the car. I release the car. Whoops, wrong way. I release the car, and it starts moving. And well, some of that elastic potential energy becomes kinetic energy, the energy of motion. But it eventually stops. So where did eventually all that energy go that I put into that car? Well, it went into the environment and as thermal energy. Basically, I made the molecules of the environment vibrate a little tiny bit faster than they were before. Not much faster, okay, but a little tiny bit faster. And that's where it kind of ends up, and that's where we'll finish. So I'm going to draw a diagram of this. Now think of all the energy that's in my hand that's going to get used here as being in this container. We can draw it as a circle. It doesn't have to be a circle. But I'm just going to say, here's all this energy, and we're going to call this chemical potential energy. And as I wind this car up, right, it's going to be, I'm transferring this energy into the elastic potential energy. Try to make them the same size. The elastic potential energy that's stored in the spring here. But when I wind this up, what do you hear? Listen very carefully. You hear sound. And also in here, there are gears where there's a little friction going on and all that. So even when I wind it by doing work, right, I'm applying a force and I'm doing work and I'm changing the chemical potential energy in my hand into elastic potential energy of the spring, but some of that energy leaks out through friction and sound, right, into the environment as thermal energy. Well, I wind this up and then I release it. Oh, it started moving. And this was through the application of a force, of this force of the spring inside here, transferred through this little transmission, this gearing system, into making the wheels spin, and the wheels applied a force to the ground and made it go. So through work, we transfer some of this energy into kinetic energy. But you probably notice that after I release the car, you hear a lot of sound, and there's a lot of gears that are interacting and rubbing. So even as we do that, we convert some of the elastic potential energy gets converted into thermal energy. And so this is work, and again, this is friction and waves, sound waves. I could say just sound. And then, but eventually this stops. Now, where does this all go? Where? Well, there's friction and air resistance and all that, and basically all the kinetic energy it had also ends up over here through waves and friction and so on. Well, all the energy that I started with, it all ends up here as thermal energy. So this is where you end up. This is where I started. This is where all the energy started, and then by doing work, I converted that energy from chemical potential energy to elastic potential energy, and then some of that got converted into kinetic energy when I released the car, but all of that energy eventually just ended up in the environment, the random motion of the molecules of air, of the table, of the plastic parts in here. And this is what happens to most of the energy that we humans use. It ends up just kind of being spread out through the random motion of the molecules in the environment. So there's a little bit more to it than this, but I think this is a really nice and fairly complete way of looking at what's happening to the energy. But here's another thing. Energy, remember, is you cannot create it, you cannot destroy it. Here's all the energy we started with. Of course, where did that energy come from? It came from the food that I ate and that eventually got stored up in the muscles of my hands and my arm. And then all of that energy that I took out of my arm ended up in the environment. So we didn't lose anything. We just changed how it exists in the world. So this is what you're going to do. You're going to do things like this. Think about where the energy begins and how the energy bounces through the environment and where it ends up. Now, it doesn't all have to end up here. Let me show you one other little example. I don't have a little toy to show you, but imagine you have a surface like this, and then on this surface is a little ramp, and then you have kind of some kind of stop right here. Okay. Now here we're going to put a marble. So imagine you have a marble right here, and you've got a spring behind this marble. It could be like a spring-loaded gun. I'm just going to represent it as the spring. Now, this spring has been squished in. So we've got elastic potential energy. And then we fire the marble. So what does the marble do? It's going to move, right? So let's take a look at the marble right here. It's moving. See the little streak marks indicates motion. So what kind of energy does it have now? Well, this elastic potential energy turned into kinetic energy. But then it goes up the hill. Now, as it goes up the hill, it slows down, right? It loses kinetic energy, right? When you coast a bicycle up a hill or anything like that, you slow down. What's happening to energy? Your kinetic energy is being converted through work, by the work that gravity does, because gravity is applying a force. It's gravity slowing you down and turning your kinetic energy into gravitational potential energy until, let's say your marble gets up here. Now it's moving a lot slower, but let's say it's moving a little bit, and then it thunks. It hits into this. Let's say it's like we have a rubber pad right here, and it just stops. It thunks right here, and it just comes to a stop. So it has no more kinetic energy. And it's just sitting up here. Well, let's take a look at this in terms of energy. We start off like this. Let's say this is all the energy I start with. And this is all elastic potential energy. Then we fire it. So the spring does work. It applies a force to the marble and pushes it and makes it go really fast. Now let's say we've hardly lost any of the energy to thermal energy yet. So let's say that this is going to be kinetic energy. So the marble's got kinetic energy. But then what happens is it goes up here. Well, as it goes up the hill, gravity does work. See, this was the work done by the spring to give it kinetic energy. But now gravity does work, and it turns some of that energy into gravitational potential energy, right? But notice I drew this circle smaller than this circle. That's because there's still some kinetic energy left, right? It still has some kinetic energy. And where does that kinetic energy go? Well, when it hits this little pad right here, this rubber pad that maybe absorbs the kinetic energy that's left to make it stop, that will apply a force here. And really, like how a foam pad works is that you actually heat up the foam pad. It has like internal friction and stuff. And so when you hit that pad, you can think of it as doing work through friction, the force of friction inside this little pad here, and it turns the rest of the energy into thermal energy. Okay, and that's where we end up. That's where we end up. Here's all the energy I started with. It turned into kinetic energy, but then gravity slowed it down, and we gained some gravitational potential energy. That is energy because this marble has height. I mean, look, if I gave this marble a little shove, I can get some kinetic energy back from it. So there's energy stored in the height, right? We have some height above our reference point, above where we started. So it's got gravitational potential energy. But we also did lose some energy. We lost some. Now, not lost to the universe. It's still in the universe. It's just we don't really have access to it. We warmed up the environment a little bit. And probably, as this marble rolled up to the top, you probably heard a little bit of sound, sound, and a little bit of rolling friction. Okay. So we did turn a little bit of the energy as it rolled into thermal energy, not just all from this. But so there you go. This is our energy diagram. And here you show where the energy is. And with these arrows, you show how the energy got changed. Hope that makes sense to you. Good luck on the lab today.